Hare Krishna. Now in this video we are going to learn about imaginary derivative factors of complementary function. Now so solving the sums, the first sum is d square y by dx square plus 9y is equal to 0. Now, as per the normal rule, we have to replace the d by dx term with capital D. The power here is 2, so writing here 2 and taking y common, plus 9, taking y common is equal to 0. Now, putting the terms in the calci, pressing the on button, the power I will show you from the start. In order to clear the calci, you have to press shift 9 equal shift 9 third. We have to, first we have to see what is the highest power of the equation. The highest power is 2, so degree of the complementary function is 2. You have to get two terms. So now in order to get the two terms, you have to put the values on the calci. You have to press mod and you have to get the equation. You have to press 5 and then 3. The highest power here is 2, so and here the highest power is 2, so pressing 3, pressing the values. First we should know that what are the values of we have to put in the calci. So d square, d and constant, d square, derivative term is not present here, and here 9 is constant. What is the value of d square? It is 1. There is no d term present, so it is 0, and the value of constant is 9. Putting the same values in the calci, 1 0 9. So now here we get 3i and minus 3i. Whenever we get I term in the calci, we have to understand that the term is imaginary. x1 is equal to 3i and x2 is equal to minus 3i. Now we should know that the formula for imaginary function is yc is equal to e raised to alpha x c1 cos beta x plus c2 sin beta x. So now what is the alpha term here? In order to get the alpha term here, we can totally write, we got 3i and minus 3i, so we can also write the both terms together as plus minus 3i, as only the value is same. The value of the both the terms are same, but the sign is only changing, so we write a plus and minus 3i. Comparing this term, in order to get the alpha and beta values, comparing it with e raised to alpha plus minus beta I, alpha plus minus beta I. So now what is the value of alpha? Alpha is a term which is not the neighbor of I term. The neighbor of I term is the beta term. So here alpha is equal to 0 and beta is equal to 3. So now putting the same values in this function equation, we will get e raised to 0x. We can write it as 1, as anything raised to 0 is 1. c1 cos 3x. Whenever we are going to take the value of beta, we have to take only the positive value. they are plus and minus 3i, but we have to take only the positive value anywhere. C2 sine 3x. If anything raised to 0 is 1, we can also write the final answer is C1 cos 3x plus C2 sine 3x. This is the final answer. Now solving the second sum to get even more clear idea, we have the question d square plus 1y is equal to 0. What is the highest term here? The highest power here is 2. So degree is equal to 2. Degree is equal to 2. Now we have to write d square. The highest term is the term with the highest power is d square. So d square and then taking decreasing the power d square d and then constant. What is the value of d square? It is 1 here. What is the value of d? D term is not present here. So we can write it as 0. And what's the value of constant? The value of constant here is 1. So putting these values in the calci, we will get 1, 0, 1. We will get x1 is equal to I, next 2 is equal to minus I. We got x1 is equal to I and x2 is equal to minus I. You can write the both terms together as x is equal to plus minus I. Now comparing in order to get the alpha and beta values, comparing this term with comparing plus minus I with e raised to alpha x, e raised to alpha, sorry, it's alpha here, alpha plus minus beta I, alpha plus minus beta I. In order to get the values of alpha and beta, we have to compare the values we got from the calci with this equation, alpha plus minus beta I. What's alpha? The value of alpha? It is 0 because no term is at the term adjacent to the I is the beta term. Alpha is equal to 0 and beta is equal to 1. The term adjacent to the I term is beta, and here we can write it as 1. So beta is equal to 1, and the term here is alpha. Now putting the values in the equation, e raised to alpha x, c1 cos beta x plus c2 sin beta x. The value of alpha is 0. Anything raised to 0 is 1. So we don't want to we don't have the need to write this. You can directly write c1 cos beta, the value of beta is 1 x, c1 cos 1 x plus c2 sin 1 x. This is the final answer. Now we are going to understand how to solve real and imaginary factors of complementary function. Before, we have studied here how to solve imaginary factors, only imaginary factors, but in this video we are going to understand how to solve real and imaginary factors. Now starting with the process, replacing d by dx with capital D, d square, the highest power is 2, so writing here 2 plus 6d plus 10, taking y common is equal to 0. Y term is common here, so taking it common out of the bracket, Now the highest power is 2, so degree is equal to 2. The now writing here d square, d and k. What's the value of d square? It is 1. What's the value of d? It is 6. And what's the value of constant? It is 10 here. Putting the same values in the calci, we'll get 1, 6, 10. We got minus 3 plus I and minus 3 minus I. So writing that we got x is equal x1 is equal to minus 3 plus I and x2 is equal to minus 3 minus I. We can write both the terms together as x is equal to minus 3 is common, so writing here minus 3, and I term is also common but the sign is different, so we can write it as plus minus I. Comparing it with alpha plus minus beta I, in which the value of the alpha term is the real term and the beta term is the imaginary term because it is associated with I. The term which is associated with I is the beta term, and the term which is not associated with beta, I term is, we can call it as alpha. By comparing we get alpha is equal to here minus 3, alpha is equal to minus 3 and beta is equal to here plus and minus I. If nothing is present, we can write here 1, and as we have got two signs plus and minus, we have to take the positive sign only. Value of beta is 1. Now complementary function for imaginary real and imaginary terms is e raised to alpha x c1 cos beta x plus c2 sin beta x. Here the value of alpha is equal to minus 3, so writing here e raised to minus 3x bracket c1 cos beta, value of beta is 1, c1 cos x plus again c2 sin x. This is the final answer. We have to use this equation when we have to calculate the real and imaginary terms of the complementary function. Solving the second sum, the question is d square plus t plus 1 y is equal to 0. The highest power in this equation is 2, so degree is equal to 2. And now we have d square, d and k. What's the value of d square? It is 1. What's the value of d? It is 1. What's the constant? Value of constant? It is 1. Putting the same values in the calci, we will get 1 1 1 1. It is minus 1 by 2 plus root 3 by 2i and minus 1 by 2 minus root 3 by 2i. So we can write it as x1 is equal to minus 1 by 2 plus root 3 by 2i and x2 is equal to minus 1 by 2 minus root 3 by 2i. We can write both the terms together as x is equal to minus 1 by 2 is common, so writing a minus 1 by 2 And root 3 by 2 and root 3 by 2, they are also both same, but only sign difference is there. So as we have done in the previous sum, we can write it as plus minus root 3 by 2I. Now comparing the values with alpha plus minus beta I, the value of alpha is equal to minus 1 by 2 and the value of beta is equal to root 3 by 2. So putting the same values in, yc is equal to e raised to alpha x c1 cos beta x plus c2 sin beta x. Value of alpha is 1, so here we are going to write 1 minus 1 by 2x and c1 cos beta value is root 3 by 2, root 3 by 2 x plus c2 sin root 3 by 2x. So this is the final answer. Of course I am going to saying it, I am going to say it again. You know, the here plus and minus root 3 upon 2 is there, so you have to assume only the plus. We are going to give only plus sign here, we are never going to write minus sign here, the answer will get wrong. So always write plus here only, and always assume the value of beta to be positive. Okay, thank you for watching this video. If anyone has any problems or any solutions, they can please comment. Hare Krishna.